Hello, this is Group 2, and we will be presenting about Newton's law of cooling for our first order ordinary differential equation group project. First, what is the first order ordinary differential equation for Newton's law of cooling? How was the equation derived? Newton's law of cooling describes the rate at which an exposed body changes temperature through radiation. Rate of loss of heat from a body is directly proportional to the difference in the temperature of the body and its surroundings. The general formula can be given as d temperature over d time, or the change in temperature with respect to time, equals to minus k bracket T minus Ts, where k is a constant of proportionality and Ts is the constant temperature of the medium's surroundings. The general solution to solve problems involving Newton's law of cooling is to first use the separable method to separate the terms to different sides of the equation. We then integrate both sides. And then, we form an equation in terms of T temperature. Finally, we add the constant into the equation. This is the problem that we've chosen for our group project. When a chicken is removed from an oven, its temperature is measured at 149 degrees Celsius. 3 minutes later, its temperature is 93 degrees Celsius. How long will it take for the chicken to cool off to a room temperature of 21 degrees Celsius? From this problem, we're able to choose and apply the separable method, determine the data given, and create an equation using the general equation and solution. How do we solve this problem? Firstly, separate the general equation, then integrate both sides of the equation. As a result, we are able to create an equation in terms of T temperature. To determine the value of constants A and C, use the data that have been given to us. Knowing that the temperature of the chicken after taking out from the oven, which is when T time equal to 0, is 149 degrees Celsius. Substitute the values into the equation to find A and C. To determine the value of K, use again the data that have been given to us. Knowing that the temperature of the chicken after 3 minutes, which is when T time equals to 3, is 93 degrees Celsius, substitute the values into the equation to find K. Finally, to determine the time for chicken to cool off to room temperature, substitute the temperature value into the equation, knowing that the temperature of the chicken after cooling off is 21 degrees Celsius. As a result, an infinite solution is formed and can be seen on the temperature variation graph here. That brings us to the end of our presentation. Thank you for your time and attention.